Alright, I'm going to go ahead and get started here today. Things we're going to talk about today, we're going to talk about the PicoBot solution from Thursday. So I'll just go over how I solved it. If anyone has a better solution or anything interesting to talk about, I'd be more than willing to talk about that as well. And then what we're going to do after that is talk about some different programming languages. So we're going to go through 5 or 6 different languages that I think are very relevant to the industry and talk about them a little bit, show you some different code, how to run it, how to get started with any of those languages if you would like, and then finally talk about assignment 8. So reminders, announcements, so assignment 6 and 7 are due tonight. We will have quiz 4 on Thursday, which will cover strings and string functions, so if you're still unsure about that, definitely go back, review some of the material in the textbook, review some of the videos. That will be on Thursday. And then finally, we will have the DST Tech exam next Thursday. So I think that's like 50, 60 questions Tuesday. And those are questions about CSC 105 and 150, primarily about 105. I don't know why we do it in this class, but we do it in this class even though there's probably more questions about 105 than 150. So just prepare to do that on Tuesday and try and not miss either of those days. So, questions things you want to talk about right now? Anything? Okay, so here's my PicoBot solution. So, the rules we have right now, it moves, push enter rules, enter go. It goes up and down repeatedly, switching between state 0 and state 1. So, what I did, so we keep this one right here, which moves it all the way up to the top. So we'll get rid of everything else. Enter rules, go. So it will move all the way to the top, and that's the first thing we need to do. So then we need to make a state 1, and our state 1 will, so again, our directions are north, east, west, south, so news. So as long as we are not obstructed to the, we'll start out with the east. So ignore the north, check to make sure we're not obstructed to the east. Ignore the west, ignore the south. And then if we're not obstructed to the east, we're going to move east and stay in state 1. All right. So let's look and see what that gives us right now. We'll reset this. We'll go again. So we're going to go all the way up to the top and then all the way to the east. And then this ends saying no rule for state 1 and surrounding like that. Because when we're in state 1, we don't match anything, we don't have any rule that matches it, so it just stops. So then what I do is once we are impacted to the east, so we say this, once we are impacted to the east, we will not do anything and we will switch to state 2. So in state 2, it's very similar, except we're moving to the west now. So check to see if we're obstructed to the west. If we're not, then what we're going to do is move to the west, stay in position or in state 2. But if we are obstructed to the west, what we're going to do is not take any action, and we're going to switch to state 3. So what that looks like right now, let's enter the rules, hit go, or reset it first, I guess. Go, so we're going to head up, head right, head left. So now we've covered one row. So after we've covered one row, what we're going to do in state 3, no, we don't even need state 3 actually. What we can do is as soon as we're impacted to the west, we'll head south 1 and we'll switch back to state 1. So I'll enter the rules, reset it, and now I think we're good to go. Yeah, so we'll head up, right, left, down, right, left, so on and so forth all the way down. So the one optimization that you could make is it is covering all of these lines twice. You could optimize that away somehow, but that's the simplest solution I had. Did anybody else have any other interesting solutions to solve the problem? Does that make sense, that solution? Okay. That's all I was going to cover with that. If you didn't notice, there are other maps that you can try to write states or rules for to cover. I think it's kind of an interesting challenge if you're interested in that at all. But that's the whole point of this example or exercise, I guess, was to start working with finite state machines. So one of the things that we encounter in working with this problem is how do we solve a problem without any variables, without knowing what we're doing? Except we can only sense directly what's around us. We can't really do anything else. So it's definitely a good problem in how to work with things without really having the information you need to actually solve the problem. So with that, we're going to move on to our language tour. So the first thing we need to talk about is really the two different types of languages. So we have compiled languages and we have interpreted languages. So when we say something is compiled, a compiler, or the act of compiling, generates the instructions to be run by the computer. So when we compile our program, we would say gcc like main.c or something, and that would generate an executable file that can be actually run by the processor or the computer directly. We can load the code that's generated from the compiler directly onto the CPU, and the computer will run it. Versus an interpreted code, so the interpreter decides what actions to take on runtime. So what that means is we never compile our code. We don't have to do gcc file name and then do a.out. All we say is the interpreter and then the file name, and then it immediately parses that file and executes it on runtime. So every time that the file is loaded, every time that we interpret that program, we need to reload it, and the interpreter makes all of those decisions on what to do on runtime. So because of that, because the interpreter is always deciding what to do on runtime, it's always going to be, well, generally slower than compiled languages. 10 years ago, you would have said always, but now with a lot of breakthroughs, people are writing interpreted languages that are have very good performance, I should say. So another thing that's fun about interpreted languages is that interpreted languages usually have an interactive mode. So that means that you can type code directly into a prompt and it will be evaluated and executed as you type it. So one of the things you might end up doing in C a lot is you might open up your file, might type some code, might compile it, run it, see if it works. But with an interpreted language, what you can actually do is just run the interpreter. It will give you a prompt, and it will allow you to type code directly into that prompt, which will be run immediately. So we'll take a look at this more when we're looking at the actual languages. So just talking more about compiled versus interpreted, one of the examples that I had here, I have this real simple program. It just declared a variable, and then we're going to return that variable. So when we're compiling this program, again, we're taking these lines of code, GCC is, and is generating an executable that can actually be run by the computer. So looking at that executable, it doesn't matter that you might not understand what's going on here right now, but we have our main label here that's being generated by the compiler, and then we have individual instructions. So that declaring I equals 0 looks something like this in actual machine code. And then the return 0 would look something like this in actual machine code. So we're translating, or the compiler is translating our source language to our target language, which in this case is assembly. So just that's kind of how it works. There's a whole bunch of other code that gets generated by the compiler, but this is the one region that actually is kind of important. So that's what's happening. But again, with interpreted languages, none of that actually happens traditionally. So the other final thing when we're talking about languages is we have to think about the standard library. So when I'm talking about standard library, that is the programs, the libraries, the functions that are included with the platform itself. So when we say standard library in C, that would be printf, ran, scanf, all of those functions that we use to do certain things. Those are all part of the standard library. And those will exist wherever you're running C code. On every platform, those functions will exist. But there's a lot of other libraries that are included, third-party libraries that are included with language that are not installed by default. And most languages can have the same power as other languages if they have libraries, but a lot of languages include more than other languages for use. For instance, basically all of the other languages that we'll talk about today have very large standard libraries that allow you to take lots of actions very easily, whereas C doesn't really have that large of a standard library. For instance, other languages might allow you to send emails with a single function call, or like draw to the screen or do graphic stuff, but C does not include any of those things. So when I say a large standard library, it usually has all of those graphics, networking, web requests, all sorts of things like that built in. And then the final thing we want to talk about is object-orientedness. So basically, I think all the languages we're talking about today are object-oriented languages. So when we say object-oriented, we're talking about combining code and data into one item. So one of the things we end up doing a lot is we have functions, we have to pass in arrays, we have to pass in things as parameters, but with objects we can combine the code and the data into one item. So when we're thinking about objects, think about them like real objects. So objects have attributes, they can take actions, we call those actions methods. And then with objects, again, all of the data and functions relating to that particular item are contained within that object. So with that, the first language we're going to talk about is C++. And C++ is really C plus just a few more minor things. So the major thing, well, minor, major, there's no syntactical difference really between C and C++, but the biggest difference is the object-orientedness of C++. So only other differences, source files do end with the C++ extension, and we compile with G++ instead of GCC. So I have this folder here of all my examples. So a real simple one here is this hello.cpp. So one of the other things that changes in C++ is instead of using printf, we use stdcout like this, and then use these operators to direct certain things and just cout. So right now, if I was to compile this with G++ again, what I would get is hello world, just like that. But some other interesting things that we can do is we could have like I equals 10. And if we wanted to output that, instead of writing a format string like we would have to in printf, all we would have to do is add that between the redirection operators, or the less than sign, and we can see that that's printed out just like that. So that's one of the changes. But again, the main change that we have with C++ is our object-orientedness. So with object-orientedness, what we're going to do is define classes. So I'll say class talker. And inside that class, what we have is public, and we have, well, I'll put private first. We have public and we have private methods and data. So when something is private, that means that nothing outside of the class can interact with it. When something's public, that means that things outside of the class can interact with it. For instance, I'll have the count variable. And that count variable is only accessible to functions inside of our class. So let's do this. Let's say void hello, and then we will declare this function inside here. So in order to be able to use this class, what we have to do is instantiate it. So I say talker t, that creates a copy of this class. And then in order to call any of the functions inside that class, I need to say t.hello. So this should do the exact same thing it did before, as long as it didn't make any mistakes. So again, G++ to compile the C++ program. Need to change this a little bit. And there we go, hello world. So it's also worth noting again, if we have a private function, so void my function, that if it's private, that means we can't access it outside of, well, we can't access it outside of the class. So we can't say something like this, my function. What it's going to say is private, so that means we can't use it outside. But if it's private, we can actually use it inside of other functions inside our object. So my function, or this dot my function. I got to delete my other one. That's right. But we can use it inside other functions. So a super simple example, I'll just do this one really quick. Let's say we wanted to have this class talker, and every time we printed something, we also printed a line number. So we're going to print, that's what we're going to do is print count, and then hello world. So every time we print something, it will print the number of lines that have been printed. So it would look something like, not like that, because we didn't initialize our variable. So another thing with object-orientedness is we have a constructor. So when we create an object like this, there's always a function that's always called when we first initialize the object. So we would say talkers, and then let's say count equals 0. Now we'll get good results, so that will say 0. So we want to increment this every single time, or we want to increment count every single time it's called. So now when we call it multiple times, it will print the line number every single time we call it. So there we go, 0, 1, 2, 3, 4. So we could add other methods to say different things too. Let's say goodbye instead. And that will still increment the count and everything. And we can see we got that goodbye there too. So the real power of this, though, is we can have multiple objects that have multiple states. So we'll just say talker m, and now I'll say m.hello. We'll say it again. Recompile it, run it again. And now we can see that, so all of these are printed with t, and this is printed with m. And once we instantiate that new class, we are going to reset our internal variables. So that's really the basics of object-orientedness. And it's something worth knowing what objects are. So again, objects contain data, so you have data inside that object, and you have functions inside that object right here. So just keep that in mind when you hear object-oriented languages. So object-orientedness isn't really required in any of the languages we talk about today, except for Java, but it's usually very powerful. So with Java, Java was written to be a better C++. People said that for a long time. So one of the things that Java does is it handles memory management for you. Some things it'll do is you don't have to necessarily allocate the exact sizes of arrays, things like that. So one of the things it also does is has a very large standard library, so you can draw on the screen with it. You can do like web requests, a whole bunch of different stuff. But the thing about Java is that it runs on the Java virtual machine. So Java is the weird one out among all of the languages, really. So what you do is you compile your code to bytecode with Javac, and then you actually run the bytecode with Java. So when we say bytecode, one of the things that slows down interpreters a lot is actually interpreting your code. So when you have code, you have white space, you have comments, you have all sorts of different things that the machine doesn't actually need to know. You have a lot of symbols that just are kind of existing there. So when you compile your code to bytecode, what it does is it optimizes kind of the structure of your program so that it can be run faster the next time you want to run it. But at the same time, you can retarget that to different systems. So I can take something that's running on my computer here and run it on a phone with a different processor with different instructions powering the CPU with the same bytecode, because the bytecode isn't specifically targeted towards any platform. It's just compiled to speed up the processing of the language. So we won't talk about Java really too much, but here's what an example program would look like. So we have hello.java. So like I said with Java, everything actually is required to be a class. So we have this class right here. But when we're running this program, Java will look for this main function. Has a little bit different structure than what we're used to. And then just like this, we would say system.out.println. There's different methods we could call on each of these sub-objects if we wanted to. And there's all of these are nested objects. So doing something like that, again, what we need to say is java c hello.java, which would generate our bytecode, and then we would say java hello, and that would print hello world. Now notice the thing that was actually generated was hello.class, but that's not what we are typing right here. So one of the interesting things about Java is it searches your directory for the class name when you run your program instead of the actual file that's being generated. So as long as your class name was hello right here, you would just say Java hello, and that would print hello world. So that's Java. Keep moving here. So the second language, we're on third now, right? So the third one we're going to talk about is JavaScript. So it's not related to Java at all. It's completely different. So JavaScript was originally designed to run in the browser and power web pages, make things float around, generate animations, do all sorts of stuff like that. But now it runs everywhere. So for example, what you would say is Node.js and then the file name. So looking here. All we need to do to print hello world in this language is one single statement. We say console.log. So we're calling the log method on the console object, and then we're printing out hello world. So Node.js, hello.js, and that prints us hello world. So one thing to note about JavaScript is there is no main function. That's the first difference that you'll notice. We just have the single statement. We still do have functions, so we can say function ASDF, and then all that function would do is print ASDF. But the code that's run is just the code fully unindented. So instead of having a main entry function, it would just execute this code. So we could copy that down a bunch of times, and it would run. So hello world a bunch of times. And again, it just, in this language and a couple other languages we'll talk about, JavaScript just runs the code that's fully unindented, such as if it was main, but it's not. So another couple interesting things to talk about with JavaScript are the dynamically typed variables. So when we are actually declaring a variable, instead of saying a data type, we just say var. And we say var 10 or var a equals 10. And instead of actually requiring that we say the data type, again, all we have to do is say var, and then we say the data we want to store in it. So if I wanted to print something like this, I could say hello world a. And there we go. So this JavaScript is our first interpreted language. So with interpreted languages, one of the things we usually see are dynamic or loosely typed variables is what they're called. So we don't actually say what type of data will be stored there, and we can actually store any data we wanted to. So let's say we wanted to go and change this to be a string or something like that. In JavaScript, that's completely valid because it's a loosely typed variable, and our data type can actually change whenever we want it to, which leads to a lot of confusion if you do it wrong, but it's also very powerful at the same time. So we just say var to declare a variable. I think you can actually even implicitly declare a variable without even using it. Yeah, so you don't even have to say var, you can just give it a value. And that's one of the things with interpreted languages is they let you get away with a whole lot of stuff that you wouldn't usually be able to get away with. So just kind of sloppy code is allowed, but it's not required. So that's JavaScript. So PHP, acronym is Personal Homepage. So it was originally designed to generate dynamic content on websites. So it has a lot of other applications. This is another one with a large standard library, so you can do a whole bunch of stuff, sending emails, web requests, tinkering with a whole bunch of other system data. So PHP was originally designed to be incredibly easy to use and forgiving. So even if you encounter errors, sometimes PHP will just keep running. It doesn't really care, which leads to a lot of security things, but it's also kind of an interesting language. So look up hello.php. So PHP code starts off with this symbol at the very top, so this less than sign question mark PHP, and then this is the print command, so we just say echo hello world, and then /n for a new line. And then we just say PHP, and then the file name we want to run. So just like before, in JavaScript, it is a loosely typed language, so that means we can put different types of data and different types of things. For variables, when you're referencing variables in PHP, we actually need to use a $sign and then the variable name. So we could say a equals 10, and then what we say to join strings in this language is a period. So you say period a, and I think that should be converted. I don't know for sure. Yeah, so I did lose my new line, but I still got that 10. So that's one of the other things which dynamically typed languages do really well is you can just convert things back and forth between different types. So if you have this string here, you can just add strings, you can add numbers together, and it just kind of works. And that's one of the things that does take a lot of work to get right in C. That interpreted languages do really well, is just kind of keeping data together. Again, I can just retype this if I wanted to. I could just change it to ASDF, doesn't really care. I'll add a new line there too while I'm at it. Did leave off a semicolon. Guess those are required. And there we go, we got ASDF. So we can just reassign variables with different types. Doesn't care at all, just gets it done. So that's PHP. So then we got Python. So Python's the best language, that's all you need to know. Designed specifically to remove all the hassles from programming in C. But the one difference that's really kind of interesting about Python that no real other language uses is that it is whitespace sensitive. So most languages ignore whitespace. You can tab things out, you can indent them however you want to. You could put it all on one line for the most part. But with Python, you actually, whitespace actually matters. And I'll show you some examples in a little bit. But just like with JavaScript, with PHP, again, it's an interpreted language. So looking at this, hello.py, all we have to do to say hello world in this language is print hello world, Python hello.py. And there we go. So just like before, to run commands, we just leave them unindented, and they will be run from order from top to bottom. So when I'm talking about whitespace sensitive, let's say I wanted to write an if statement. So I say if 10 is less than 20. So the first thing you notice is you didn't have to type any parentheses, so that's nice. And you also didn't have to type any brackets, so that's also nice. So what Python does is it detects to see if, the way it detects to see what code will be run if this condition is true is it finds levels of indentation below that block. So I would say print ASDF I equals 10 plus 20, something like that. And all of these statements, so long as they're indented one level of indentation further than this block right here, will be run. So just looking at that, we'll run that again. Hello.py, and we got ASDF printing there. So it's all about levels of indentation, which also helps to enforce, I guess, pretty code to be generated, because it's always forced to be indented properly, or else it's not going to run. Because let's say I did something like this. What's going to happen is it's going to give me an error. It's going to say expected an indented block, because it expected an indented block, really. And that's how we indicate blocks in Python, is just with one level of indentation. So a couple other things you could say, a couple other things that are interesting. Let's say you had an array, so I'll say A equals, when we make an array, we'd say like 10, 20, 30. A couple other interesting things that you can do is you can say for item in A, and then you're just going to print A. So this for loop syntax that Python has really simplifies the syntax that would be a C loop, and is just kind of nice, actually. So run that again. We can see that we didn't get what we wanted. Oh, I need to print item, not A. There we go. So we got 10, 20, 30 there. So one of the other things you might have noticed is we can just print like arrays and things like that. So one of the things we have to do in C is we have to write a function to print an array. But people in Python were like, we don't need to do that every single time. So we'll just include that in the language. So you can just pass whatever you want into print, and it'll just get it done. It'll print it out without really any work being put in. So let's say you wanted a traditional, like, I equals 0, I is less than 10 range, sort of like that. You would say, instead of saying all of those different conditionals, you just say for item in range, and then it would go from 0 to 9, I believe. So there you go. You got yourself a nice little range, 0 to 9, with a real compact syntax, and it's just real nice. Python's just a really nice language. So the final one we want to talk about is Go. So out of all of the languages I've talked about, this is the newest language that was released by Google in 2009. All of the other languages we've talked about have been around since the 90s. They were all developed in the 90s, and they have been around forever. And for the most part, most of the languages that are used haven't been really modified that much since they were released. But there are a couple changes. So the whole point of Go is it's the power of an interpreted language, or a language, with the performance of a compiled language. But one of some of the odd things that, at least I think, there are a lot of odd things that were changed in Go that weren't necessarily required. So, for instance, looking at this, like, this is how you would declare an array of 10 integers in Go. And I just don't, maybe it's just because I've worked with C for a while, but I don't really think that makes a lot of sense. But at the same time, Go is very powerful, allows you to do a lot of things that you'd never be able to do in C, and you'd never have the performance you need to do in Python at the same time. So I don't really know a lot about Go, but it's definitely a really great language. It's really taken off now, but I do have this short example. So I have hello.go. So you need to say what package you're in. You have to identify what file you are in. So you'd say import format, and then you have a main function just like traditionally, and then you say format dot and then the method you want to call. And there's things like printf and scanf, I believe, in here that allow you to do more complex things. But that's how you'd write a very basic Go program that printed hello world. So to run that, you'd say go run hello.go, and that will run it right off. Or if you want to compile it and use it later, you just say go build, and that will generate this hello program right there with the same name as the source code. And there we go, we got hello world. So that's all I have for the language tour. So there's a couple other languages that are kind of powerful that I think of. There's also, if you want to get into this more, look at Ruby, look at PowerShell, look at C#, and then you're pretty much good for learning the languages that you ever really need, because those are pretty much all of them. So anyway, the reason we've been talking about this is for Assignment 8. So for Assignment 8, I want you to select 3 of the programming languages we talked about today. So I want you to go back. I want you to implement Assignment 3 using each of these languages. But in addition to your source code, your program for each of those, for Assignment 3 for each of those languages, you should also create a text file for each programming language you use. So at a minimum, you should describe the language history, the reasons why the language was created, the differences between the language and C, why people use the language, and what major software projects have been written in the language. So you should create all of your files inside a folder, then zip the folder. So your structure should look something like this. So you have a program.java, program.py, program.js, and then for each of the languages that you use, a text file. So if I pick Java, Python, and JavaScript, I expect to see a java.txt, python.txt, and javascript.txt in that folder. So looking at this is also worthwhile. So let's say this was my folder that I'm working in. I'm working in this lang tour folder. If I wanted to zip that up, what I'm going to say is zip-r langtour.zip and then langtour. And that will create a zip file called langtour.zip, which will contain all of the files that I need to submit. So when you go to submit your program, I want you to, again, create all of your things inside of a file, and then zip it up, and then you'd say submit langtour.zip. And that will submit all the files that you have to the Dropbox so that I can look at them. So I think that's pretty straightforward. So just like all assignments we've done this semester, pretty much the same, so worth 10 points. And then do a week from today at midnight. So that's all I have for you today. If you want to stick around and work on Assignment 6 or Assignment 7, ask any questions, finish anything else up, well, let me know.